Take a look at page 149 in your student journal. What we're going to be looking at are inverse functions. If we have a function to start with, we want to know what does the inverse look like. The inverse may or may not be a function. So the original is always going to be a function, but the inverse may or may not be. So the first way we're going to look at this is with a graph. So here's our original function right here, this line. One way to think of the inverse of a function is that it's a reflection over the line y equals x. So we're going to reflect this line over the line y equals x. So I'm going to take a point. This point right here is -2, -6. If I reflect it over this line, y equals x, that means x becomes y and y becomes x. So my new point's going to be -6, -2, which is right there. This point right here, that point is at 0, -2. If I do the inverse, I switch x to y and y to x. Now my point's -2, 0. Let's do one more point. This point right here is 4, 4. If I switch x and y, it's still going to be 4, 4. So that point does not change. So now to graph my inverse, I'm just going to connect those dots that I have. And if I connect those dots, here is the result. So that's the inverse function. Can you see how all it did is it just reflected over the line y equals x? So that's a graphing way to think of inverses, is switching x to y and y to x. Let's flip over to page 150 and we're going to look at the algebraic way. So inverse functions, to find them, to find the inverse, here's what we do. The first thing you want to do is change f of x to y. And we just do that because that's what f of x means. F of x means the same thing as y. So if you have f of x in the problem, you're going to write it as a y. The next thing we do is we switch x to y and y to x. The next thing we do is we solve for y. And the last thing we do is we rewrite y as f to the -1 of x. So we're going to go back to this function that I had over here. And I want you to look at this equation. Think about what this equation would be for this line. It had a y-intercept of -2, and we went up 2 over 2, up to, well, maybe not exactly -2. Let's look at this point here and this point here. So if I'm looking at this, I can see that the slope of this is going to be, it looks like it's actually up 2 over 1, maybe. That line's kind of hard to see. Let's actually make up a new one. That one was too difficult to tell exactly what it was on the slope. So let's go with this example. Let's say that we start with f of x equals x minus 3. So if I want to find the inverse of y equals x minus 3, the first step is to change f of x to y. The next step is to change y to x and x to y. The next step is to solve for y equals. So I'm going to add 3 to both sides. So now we have x plus 3 equals y. The last thing is to rewrite this as f to the -1 of x. So here's our original function, and here is the inverse of that original function. Original function, inverse. Now, if I want to know whether this inverse is a function, all I have to do is think about that being a line. If I wanted to do a quick sketch of this, this has a y-intercept of -3, a slope of 1. So here's my original function. My inverse has a y-intercept of +3 and a slope of 1. Is that going to be a reflection over the line y equals x? It's not perfect because I didn't have a graph paper, but can you see how if I take this and reflect it over y equals x, it would turn into the red one? So that shows me that they're inverses, and that the red one is a function and so is the blue one. All right, let's go back up here now. If we're given this function, it's a function because it passes the vertical line test. We use the horizontal line test to tell whether or not the inverse will be a function. The horizontal line test we're going to abbreviate as HLT. It says that the inverse of a function is also a function if and only if no horizontal line intersects the graph of f more than once. So if this is my original function, this horizontal line is only going to touch it one time. So that means that the inverse is a function. Here's this parabola. If I do the horizontal line test, is it touching just one time? How many times? Twice. So therefore the inverse is not a function. If I were to graph the inverse, if I were to reflect this over the line y equals x, it turns into this. Is that a function? No, it's not. This is not a function because it doesn't pass what? The vertical line test. So can you see how those are related? Like you really could just graph the inverse function and say, does it pass the vertical line test? Or you could look at the original function and say, well, that's a function, but because the horizontal line test doesn't work, the inverse is not a function. Okay? All right, let's do a couple of examples here on finding inverses. Let's go ahead and take a look at number 1. So this is f of x. So I'm going to change my f of x to x equals. My x turns into a y. So I did this in 2 steps. This was y, I turned it into x. This is x, I turned it into y. I have to solve for y, so I'm going to add 1. I'm going to divide by 2. And so f to the -1, that's how we write an inverse, is equal to x plus 1 over 2. This should just say, this is exactly what you're going to do on your homework too, guys. No matter what the directions say, you're going to solve for f to the -1 of x. That means solve for the inverse. Then you're going to find f to the -1 of whatever number they give you. You're given -6. So f to the -1, which means the inverse of f, I forgot to put the -6, is going to be -6 plus 1 over 2. And so that's going to be -5/2. So there's our inverse, and there's what we get when we plug in -6. We're going to do one more. Let's do this one. So solving this one, what's this really equal to? Y, so I turn y to x. I turn x to y. Solving this, I'm going to have to subtract 1. Now what do we do? Divide by a negative first. You got to divide by a negative before you take the square root. So this is going to be -x plus 1 equals y squared. Now what do I do? Take the square root. So when I take the square root, do you remember what we have to put in front? Plus or minus. So plus or minus the square root of 1 minus x. I just switched it around. So now, hello. Sure. Bye. Kanaya? Yep. All right, so now this is going to be our inverse function, so we're going to rewrite it. So there's our inverse function. What about if we plug in -6? Well, we would have 1 minus -6. And so what's that going to give us? Plus or minus what? Radical 7, right? Because it's 1 minus -6. Is this inverse going to be a function? What's this original shape? Parabola. Is the inverse of a parabola going to be a function? Let's say you were taking a test and you weren't sure about that. You don't need to put this in, but just watch me put it in. If I put this into my calculator, I've got 1 minus x squared. That's my original function. I'm going to now put in this function. I have to put in 2 to actually put this in. I've got to put that one in, and I've got to put in the negative. I don't need that squared up there. Okay, I'm going to do a zoom 6. Here's the way it looks. Here's my original function. Here's what the inverse looks like. Can you see that the inverse is not a function? The red one is not a function? All right.
How is the original?
The original is the blue one, and it's a function because it passes the vertical line test. The original one does not pass the horizontal line test, which means its inverse is not a function. It doesn't mean that it's not a function. It means the inverse isn't a function. All right. Just going to do one of these down here. It says to find the inverse of the function, then graph the function and its inverse. Let's do a tough one. Instead of doing this one, let's do this one. All right, so to find the inverse, I'm going to have to switch my y to x, my x to y. Now, what's a quick way to get rid of these fractions? Multiply by 8. Good. So now I'm going to get 8x equals 6y plus 5. So now I have to solve for my new y. I'm going to have 8x minus 5 equals 6y. So that's going to give me y equals 8x minus 5 all over 6. So my inverse is going to be this over 6 and this over 6. So 4/3 x minus 5/6. That's going to be a little tough to graph, and so is this one. But we'll just do our best. Well, that's not even a good axis, but all right. Okay, so to graph this one, I would go to 5/8, which is right about here. I'd go up 3 and over 4. Connect those two. So there's my first function. And then graphing my inverse, this has a y-intercept of negative 5/6, and it has a slope of 4/3. So I'm going to go up 4. Hold on, did I just graph that one? Did I graph this one right? I went to 5/8, I went up 3 over. Okay, I'm doing this one now. So I'm going to go to negative 5/6, and then I'm going to go up 4 and over 3 and connect those two dots. And if we have the correct inverse, they should appear to be reflections, a reflection over the line y equals x. Can you see how that line y equals x would go up right in between the two? Okay, so that's what we're doing with the graphing of both. Okay, last thing here, determine whether each pair of functions f and g are inverses. then explain your reasoning. What does it take to have inverses? Flip the x and y. So take a look at those on your own and decide if these are inverses and if these are inverses. Is the first one an inverse?
No,
Why not?
it's the last one.
The last one right here, do you see what they did to you? They make everything work out right, except they made, if this had been a what does this need to be? Positive 1, then it would have been, right? But they made it a negative 1. So no, because of the negative 1. All right, what about this one? Did x become y? X did become y, but did y become x? No, so this one's not either. All right, so that's all you're going to be doing is that kind of thing.